In this video, we're going to go over a few examples on how to complete the square. So the reason we want to complete the square is so that we can take a quadratic function in standard form and put it into vertex form, and then we can very easily see what the vertex of the parabola would be. So first thing I want to do is I want to get rid of this c term right here. And since this is minus 15 and I'm moving it to the other side of my equal sign, I need to do the opposite, so I need to add it to both sides. So I'm going to rewrite what I have, x to the second plus 12x. I'm going to leave a little space here, is equal to 15. Now what I want to happen is I want this left-hand side here to be a perfect square trinomial. And whatever I add to this side, since this is an equation, I have to add to the other side. So to get that number, I'm going to take whatever b is, I'm going to divide it by 2, and then I'm going to square that number. So here, for this quadratic, b is equal to 12. So I'm going to take 12 divided by 2. Whoops, that should be to the second power, not the sixth power. So 12 divided by 2 to the second. 12 divided by 2 is 6. And 6 to the second power is equal to 36. So 36 is what I'm going to add to both sides. Again, this is an equation. We have to keep it equal. What you do to one side, you have to do to the other. So now, this left-hand side is now a perfect square trinomial. So I'm going to factor it. So I'm looking for two numbers, which are going to be the same, that multiply to 36 and add to 12. And those two numbers are 6 and 6. So if I were just factoring this, it would really be x plus 6 times x plus 6. But since they're the same exact thing, what I can do is I can just rewrite it as x plus 6 to the second power, because this 2, the exponent, tells us that we're multiplying this x plus 6 out 2 times. So vertex form, it's always a binomial raised to the second power. Over on the left-hand side, I'm just going to combine like terms. So 15 plus 36 is 51. Now, to get it into true vertex form, I then have to get this set equal to 0. So since this is positive 51, I'm going to go ahead and subtract 51 from both sides. Now, I can't actually subtract 51 from 6 because this 6 is kind of protected because it's in the set of parentheses with this square up here. So I'm just going to rewrite it as x plus 6 to the second minus 51 is now equal to 0. So this right here is vertex form. And from that, I can very quickly determine what the vertex is. So the x-coordinate of the vertex is this number inside parentheses, but with the opposite sign, so negative 6. And the y-coordinate of the vertex is the number outside with the same sign. So the vertex for this quadratic is negative 6, negative 51. Let's try another example. Excuse me. So same thing. I know this one isn't set equal to 0, but I'm still going to do the same thing that I did before. I'm going to take this negative 10, this c term, and I'm going to get rid of it, and I'm going to do the opposite. So since this is minus 10, I need to add it to both sides. So we now have x to the second minus 10x, leave a space, is equal to 15, since 5 plus 10 is 15. Next, I need to figure out what am I adding to both sides. So I'm going to take my b term, I'm going to divide it by 2, and then I'm going to square it. So negative 10 divided by 2 squared is negative 5 to the second, which is 25. So I'm going to go ahead and I'm going to add 25 to both sides. All right, over here on the left, I have a perfect square trinomial. So two numbers that multiply to 25 and add to negative 10 in this case, since this is minus 10x. Since that b term is negative, I need both of my signs to be negative. So this is going to be x minus 5 to the second power is equal to 15 plus 25 is 40. I need to get this set equal to 0, so I'm going to subtract 40 from both sides. So I have x minus 5 to the second minus 40 equals 0. This is vertex form. And my vertex is the x-coordinate comes from the number inside, but the opposite sign, so positive 5. My y-coordinate is a number outside with the same sign, negative 40.